Hey guys, hope you're good. This is Max from MHS Prod and today we will do an incredible tutorial. First of all, if you're new to this channel, I really invite you to join our Facebook group called Motion Designers Community. You will be able to share your work, talk with people, meet great artists, and of course check out our Instagram page Motion Designer for daily inspiration. This tutorial is pretty nice. It's going to be a beginner tutorial. We will see how to create this kind of effect, and it's really nice because you can adapt it on mostly every object, and we will see how we can create a nice variation. This tutorial is an update from a Ben Watts tutorial, a really great one called Shortest Path Growth. And it's been an incredible inspiration. I've learned so much with this tutorial, and it's also taking the Toad Storm Henry Foster techniques that I found on the Odd Force forum. Like he was updating the Ben Watts tutorial with his technique, and I'm a bit updating the thing, and this is what I love with education and sharing, because in few weeks I guess someone will find how to even improve the setup and make it even further, bigger and better, maybe faster. So huge thanks to Ben Watts and to Henry Foster, because the technique is 100% their technique and not mine. I'm just updating it and making some stuff with it. So feel free to check Entagma, really great tutorials, and Toadstorm, like just watching his tutorial is just mind-blowing. This is a mind-blowing artist, and is one of the guy working on the motion operators, a set of really nice tools for Houdini, and I highly suggest you to check out. So just after this small introduction, let me show you what we will do with this technique, and I will also explain every step, so every people not familiar with Houdini will be able to understand what's going on. At least it's better if you already done some Houdini, because we will do a bit of coding, but you can, as a curious, follow this tutorial. The nice thing about this technique is all about the growth. It's an uneven growth. The Ben Watts technique is pretty simple to create, and it's pretty simple to animate, but there's one thing, it's like all even, and that's nice to have a nice even effect. You can create really nice effects. It's all based on the topology, so if you change the topology, it changed the effects, and it's pretty great to see all the things you can do, but it's growing all with the same length. And the nice thing about the Toadstorm technique is like it's uneven, so it's like growing, and you can see that every shape is not growing with the same at the same time, and that's the beauty of the effect. It looks even more organic, and so we will see how to create that and how to improve the setup to make it a little bit more like organic like that. So I will add a bit of Verb, I will add a bit of polyreducing, dividing. I will change some stuff from their techniques to make this one, and we will see how we can make an asset, and I'm sure people will see how to improve this technique and go even further. So I hope you're ready after all this talking, and let's make some Houdini. Now let's start. I will create a grid into the object network. So you can go here and hit enter or hit tab, type grid, and then you can click. So you have your grid. You need to double click to enter into the network, the sub-network. So we are in the network grid. Here you can see all your different networks. We will do a bit of materials with Redshift just after, so we will dive into this. and we will set the final redshift parameters here. So don't be confused by all that. It's really simple. So all the things you made at the object level is happening in the object network here. So you will have your different objects, and inside each scene you can have a bunch of objects. It's like subnets, and you can even create subnets inside subnets. It's pretty easy to understand, but so you will be able to understand when I will dive into another network. So after having the grid, I will also make a sphere just to have the comparison. I will highlight the sphere and I will set it to polygon, maybe at frequency of 6. And we will create two groups. So again, hit tab, type group, and we will change the group name to start, group type to points, and I will group points. So if I highlight here, I can see that each point has a number. So I can choose base group points, a range of points, or more than that. If you want to know more about grouping, you can click here and you can dive into the Houdini help, and it's pretty useful because you will understand how it works, but you will also get an explanation of everything. And if I type groups, let's go to groups, and I will have here more infos about the syntax. So pattern, for example, if I click, if I use this symbol, I will group everything. I can use group names. I can use range. For example, if I go from 1 to 10, it will group 1, 2, 3, etc. And I will not explain all that, but if you don't understand what I'm doing, it's like really easy to go into the help and at any moment learn more about what we can do. So to start, we will for example, start at the at this point. So I will type the point number. If I connect my node here, the group will be active. So you see that my point, it's in highlight here. So it just selected my point. So that would be the start point of my growth. Now I will create another group. And this one will be a point group 2. And this one will be called end. I will use a small expression called $n, and this will allow me like to reach all the points. Okay, so it will start from this point and then it will propagate to reach all the points following the end group. And now I will use a node called find shortest path. Let's connect our node. Let's go here and let's change the output path from any start to each end, because I want to reach each end. Let's select the start and let's select the end group. And you can see that it works and it makes a pretty nice result. So now if I want to animate this, Ben Watts show the curve technique, and it's pretty simple. Just have the curve, just highlight this. You can use the first view, but you can also choose the second view, and it will be more accurate in our case. And you can see that it makes this nice effect, and it follows the topology. So that's pretty great. Or I can change my effect. I can change the topology to have different effect. So if I choose, for example, to go here and create as an example an extrude, so let's type extrude. I go here, I select a small distance, I divide into individual elements, maybe go here, maybe have a bit of an inset. If you come back at the end, you will see that it's following the topology, so it makes a really different effect. And I can have even more influence. As an example, I can choose polyreduce, go here, and if I play with the percent to keep, it will change the shape. So let's make a few changes, and let's add a divide node. And with the divide node, you have a pretty cool option called compute dual to make nice X patterns. And you will see that it will follow the patterns. So pretty nice, pretty great effect. So how do I create a more complex setup of that? Let's first create more variation into our topology. Let's create a point VOP. So hit tab, type point VOP. Go here, highlight the point VOP. Maybe let's choose to have a bit more frequency, like 12. Double click, and point VOP will allow us to code with nodes. So it's pretty useful to create a bunch of things, but you can use instead an attribute wrangle and type everything in the expression, the language of Houdini. So you can like use both, but sometimes VOP is really faster than vex, than attribute wrangles. And sometimes attribute wrangles are really faster to create something in point VOP. You must also know that point VOP are always easier to compute than full code. But I'm not like a coding or technical artist, so I use as much as possible VOP because they are sometimes easier to understand. So dive into it, and we will grab the position of our points, and we will add a bit of turbulence. So type turbulent, and you will have the turbulent noise. Connect the position into the position here. Let's change the noise. Let's keep the noise 1D noise, and let's connect the noise into the color channel. And you can see that I have applied noise. Let's right click here. Let's go to Vex VOP option and create input parameters. It will allow me to control all that parameters outside of the VOP, and it's going to be easier to use. So all our parameters are here, and I can make few change, for example, to get rid of all that. If I just want to have controls, let's call that as an example controls. You can select color as an example. Let's have this in red, and you can add a small note for yourself in the future or for a collaborator, and use red nodes or controls are over red nodes. Can even change the color here. So if you are diving into in the future in your file, you will remember all the things you've done. So let's go here. You can go here, edit parameter interface, and you can get rid of all that. So hit shift, select all that, and you can just set them as invisible. so you can still have them, but they will not be displayed in the Verb. So you can really focus on things you want to control instead of a bunch of useless parameters. Now let's change the roughness of the noise, maybe point, I don't know, just choose a low value because you will maybe need to change it depending the object. Let's change the amplitude and have something big to have black and white areas. And we will use this black and white data to control our polyradius. So if I go over the polyradius, you can see that it's reducing using percentage to keep, and it's quite random, like it will be even all around my sphere, but I want to have more reduction and less reduction following the color. So I can do that. I can go here, make reduction sensitive to attribute, and hit the plus. And here I will just type CD. And why I'm typing CD? Because CD is the color attribute in Houdini. In Houdini, you must know that you have some like pre-made attributes, like P for point position, you have P scale for particle and point scale, you have scale for scale, you have orient for orientation of copies, you have CD for color, you have a bunch of things, and you can also create your own attribute. So you must know that there's few like pre-made attributes, and that you can also create your attribute with values and different type of stuff. So now let's see what it does. CD, and let's polyreduce all that, and you can see that it's not making something even, and that's pretty great. You can see the difference here. I can change over my control the frequency of the noise if I want something different, and using the divide it will create really more variation, so the growth will be even more organic. So that's a way to create some variation, and I can get rid of the color using an attribute delete. And why I'm using an attribute delete? Because an attribute is like exists till it's deleted. You can see it in the geometry spreadsheet. You can see your attributes here. You have points attributes, you have vertex attributes, primitives attribute, and all that. And you can also middle click to see the different attributes, and that's why I still have color after my attribute Verb. And that's the difference between an attribute and a variable. A variable is just like existing in a line of code, but we will see that just after, because we will make some coding and you will understand the difference. So all that to say, just delete the color and its primitive attributes here. That's why I didn't found it into the geometry spreadsheet, and now I get rid of the color with this attribute delete. Can sound complicated, but once you get the logic, it's easier to understand. And now what we are going to do, now we want to change the space, the clip space, to use to control everything with the clip node and not with the curve node, because we will be able to add some jittering to all of that. So now let's use Resample node, and Resample node will allow us to resample stuff, but it will also yo, it's making pretty interesting shape. But we don't want to resample, we want to get the curve view attribute, and curve view attribute will create some datas over the point. Once again, if you feel lost or if you want to know more about a node, the Houdini doc is pretty clear about stuff. The harder is like to know how you can use each attribute. I hope this beginner tutorial is all clear. I know it can sound a bit boring to someone already familiar with Houdini, but I'm trying to make this tutorial like if it was one of your first Houdini tutorial. Then we will use a small node called rest, and rest will create an attribute called rest, and it will allow us to save the point position. So if I make some deformation or some stuff, I can come back to the original position. Right now, I will use a bit of code, so I will use a node called attribute triangle, and I will be able in this node to type the expression. Let's think about a few things about code. So code is like you read the code line by line from the top to the bottom. A line is ending with a semicolon, so if you don't have a semicolon, like the line is not finished, you can use loops to execute a few lines of code and execute them few times. You can also create condition using if, then, and you can also add comments using two backslashes. So if I type hello, it's just a comment, and here you see it's in white and it will be actual code. You must know that in code we will have attributes and variables. So variables stores data. You need to tell which variable is the value of the variable and the type of variable. So if my variable is a float, I type float, I type the name, and then I say the value of the variable. And if I use if I create an attribute, I will need to use letters. So F for float, it could be E for integer, V for vector. I will create at, and I will type it. So that's the difference between a variable, and the variable will only exist in this like pile of vegs, and an attribute will be created and will be still exist till it's deleted. So the common types of variable are int for integer. You have float, so integer like 1, 2, 3, 4. Floats are values with some not integer numbers. Vectors is a collection of 3 float values. For example, color, it's a RGB, so vector, or also could be position. An array is a list of position, so you have a array, you have matrix, you have a lot of matrix, but there's like grid of float values, and you have a string. So string it doesn't work here, but strings are like a text variable, and you can find them if I go, for example, here, if I go and I want to check some syntax, for example, I type point cloud. Let me show you an example. Point cloud. Okay, let's go to the point expression, and you can see here how to create, for example, point. Read the point attribute value from geometry. You choose the type, you type point, you choose geometry input, so it could be like 0, 1, 2, etc. You have a string, so you will need to type the actual attribute name between let's say p, for example, like that, and the integer, so prime number, so 0, etc., etc. So that's the syntax for the common type of variables. As I said, attributes, you will need to use the at before, and you will need to specify the type of geometry. So it could be f for float, v for vector, s for string, e for integer. So for example, e, a. That's the difference. And then you have a bunch of other things. For example, you have if statement. So you have less than, you have less or equal, you have equal to, and equal is to equal if you use an if statement, because equal is like to define a value, but if you want to make an if statement, you need to equal. If you have this is not equal to, and you can combine, for example, using that, you can be able to create an AND, so it will take both parameters, or you can also create more than that using more symbols. So I just want to explain quickly what I will do, and I think that's all at the moment, but code could be complicated if you start, and even myself, I struggled a lot at the beginning, and I will basically just reuse the code from Toadstorm. So I didn't like made something like that. I'm just like using what he made. So the first thing we will do is move to the UV space where y is curve view. So you can have at p it equal to set. So we'll use a set expression. If you want to know more, you can also highlight an expression, and if you hit F1, it will open the related help. So set, it will be 0 at curve view, the attribute we just created before, and 0. Now I want to get the primitive number of this point and set it as an attribute. So I will create an integer called primnum, and it's going to be an array. And I will type pontprims 0 at attribute ptnum, and ptnum is an attribute that you can find in Houdini. We also find it here, see, ptnum. So you have also here an idea of all the existing attributes like time, ptnum, numpt, p, v, age, id, cd, uv, n for normal. So, and then I will say e at prim num it equal to prim num 0. So let's connect that to here, and let's see what's going on. And I just end with this this small line. And now I want to go further, and I want to create like a jitter expression. So it will like jitter along y based on the on this attribute. So up everything is up everything is clear. It could be unclear, but Let me know in comment if you have some struggles. I know it's a bit complicated, but let's see. So let's create another attribute triangle. Let's connect the other attribute triangle here, and let's create a float called jitter amount. So you can type AMT. So I'm just like using the code, as I said, from Toadstorm. You can also change the name. Is not really important. Like you can change the thing. It's just for you when you will read it. And we can create a slider, and the slider will be channel. So I can type ch, and I can create a channel of float value if I type ch. But if I want an integer, I can use chi. Now I will open the parentheses and I will select create a name, so I can type jitter amt, and I will hit a semicolon. And when I will hit this button, I will create parameters, and I will have sliders to control all that. So I'm create like a jittering amount, and I will also create a seed. So let's create another one called seed, and let's create another channel called seed. Now let's use the float y, and let's type let's create a fit expression, so fit range. It also exists in the Verb, and it's clearer to understand if you never use them in the Verb. So a fit range is like something that allow you to remap values. So you have like a source min, source max, and you can change it to different. So as an example, 0 and 1, let's say it's 100 and -5. I could say that -5 will be 0 and 100 will be 1. So that's what the fit expression is doing, but here the syntax is different. And I will create also a random. So I type rand. I at prim num plus a seed 0 and jitter amt. And again, seed is related to this variable, and jitter amt is related to these values, to this variable. So if it's called jitter with 2g, I will need to add 2j here. Again, I apologize for my French accent. It could be hard like to stay focused on a tutorial and sing and talk at the same time. And now we will set our p. So p will be equal to set 0 p dot y. So only the y. So if you add a point y, for example, after p, it will just take care of the axis here, plus original y and 0. And now I should click here, and I will have a jitter amount here and a seed. So right now what I want to do is to add a clip, to control our effect, because we will not use the curve to control, but we will use a distance here to control what's going on. So let's come back to our original state. So let's use the attribute triangle. Let's put the attribute triangle here. And now let's type at p it equal to rest. and let's see if that worked. Like that's the Houdini, and I'm like, I hope this will work. So the latest thing to make it work properly is to change keep primitive above the plane to go to primitive below the plane, and you can see that the effect is really interesting and organic. I love that. So let's select Redshift. Let's go into our parameters and let's make few changes. So first of all, I select some global illumination, setting brute force and irradiance cache. I now add a light dome to be able to light my scene with an HDRI. I will choose an HDRI that I use quite often, and I will add a backplate, so all the background will be black at the rendering. I need to create a webcam, a cam, not a webcam. Most of the time Redshift is like creating a camera for us, but sometimes it can like forget, so I need to set it in the scene. I need to select my camera and tie view to camera, and you will need to make that even if you already have your camera. You have all your strands. Let's go to the render view. Let's open the render view and let's see what it does. And at the moment I think it will not do something, because we need to set few things at the object level. Let's go to the object level. Let's go into Redshift object. Let's go to strands and let's click render object as strands. You have different options. I personally love cylinder, but I will stay with strip as it's a really fast render. And I don't have my color, so how do I get color on that? I need to create an attribute. I need to create a material and grab my CD attribute because I already have a CD attribute. But if you don't have color, you need to create first your color attribute. So let's go into the VapNet. Let's create a material builder, RS material builder. Let's dive into it. And let's choose material. So let's have our material. Let's plug it here, and now I will go here into render and select my material path. So let's go to matte, let's go to Redshift VapNet, and let's hit accept. So now I need to go back to my material path and I will type RS point attribute, and I will be able to use CD. You must know that sometimes it will not work because you will need to have some object that you can render as curves, or you can may end up with some bugs sometimes with this technique depending the object, because you will need to convert it in Houdini. But here I had a simple setup with polylines and it works properly. Actually, I didn't try it out with our previous scene because I just had a crash. And if it doesn't work, please let me know. But at last, you get the technique to render in Redshift using point attributes. Hope you guys enjoy this video. Feel free to check everything, and also I would love if you can let me finish this video telling you that we've opened a Patreon with the motion designers community with a bunch of really nice tutorials, including free and private tutorials. And the first three tutorials made by myself are here to help you begin with Houdini and create interesting shapes. And there's like no code and no vex at all. So I will show you all the things you can create. And it's pretty interesting. So you will be able to create all those shapes without any coding, and you will get all the Houdini basis really quickly. That's the result from the second tutorial. Pretty interesting. And those tutorials are designed from people for people who comes from Cinema 4D. So if you want to learn how to create all those interesting things and maybe go further and create different type of stuff, feel free to check out our Patreon tutorials. And they are not that technical. It's really designed for someone that never touched Houdini before. Thanks again for watching this video. Big up to Ben Watts and Todd Storm. I hope you guys will have other ideas to improve this setup and make some growth even more interesting and different, and you will be able to adapt this setup just by changing the main object, and it's going to be really great because you can change a bunch of things. See you guys.